Hey guys, what's up? Eddie Aho here with KissAnalog.com. All right, today's video, this could be the most important video you've ever watched. No, seriously. Grounding. I've done videos before where I've talked about grounding. I'll put a link down below. I did kind of a long video, kind of walking through diagrams and things like that. You know, talking about how power comes to your house and grounding rods, all that kind of stuff, right? So we all have to understand how grounding works. Safety grounds, chassis grounds, earthing grounds, all these different grounds, right? And it gets really confusing. So I'm going to really simplify one thing that is ultra important. And this one thing will cover a lot of those things, even no matter what you call them, okay? Ground is so misunderstood. I've talked about this before. I've got a video where I really spent a lot of time talking. I'm going to try to make this a short video because I want a lot of people watching it, because I'm going to really simplify this. On our schematics even, we put all these little ground symbols everywhere. I mean, people have gotten carried away with that. They can't draw a freaking line connecting them anymore. But we should. You only put those little ground symbols on your schematic where it's going to get messy. Like, you got to draw this down here, jump over this, and then come over here and tie the ground. You put a ground symbol up there. Down here where you have 20 ground symbols, stop doing that. Man, that is ridiculous. It makes your schematics look cartoonic, okay? Seriously. Ground is part of your circuit. You have to show your return paths. You want your grounds to come in and say, hey, it comes in here, goes in and connects to all these things. Maybe it comes down here, comes up here, and then it sprays out to all these because this is a quiet ground. So draw your schematics showing your ground, how the current flows. It's a very important part of your circuit, guys. It'll really help board layout too. This battery, if you're powering something up at this, negative terminal, red terminal. So this is negative or is it ground? It's whatever you want to call it. What if you want to use this as a negative 12 volts? Well, then you could call this your ground. It's a return path, right? Current electron's going to leave here, go through a bunch of stuff, come back here. If you're going to say positive current flow, like most of us kind of talk that way, current goes out your positive, goes through your circuit, comes back here, right? Your holes flow, the whole flow, right? So conventional flow versus electron flow, whatever, doesn't matter. It's a circuit, right? So it does. You can call ground whatever, you know, in the middle of your circuit somewhere, you can say that's your ground because it's a reference point. It's just a reference point. Whatever you want to call your reference point as your zero reference. And that only means that when you take a voltage probe or something, that you put your lead there, that's your zero reference. Everything else, you're reading a voltage differential from wherever you're reading to that point. And so, you know, ground is just misused, okay? Then you have safety ground, and you have earth ground, and it kills me when I watch a lot of YouTube videos and watch how people put systems together, because I want to do this system. I'm going to show you this inverter in a moment. But, so, you know, people, whether they're getting the grounding connected right or not, a lot of times it's wrong, and there's, and I've seen some cases where it's just super unsafe. Whether you're building a system, a solar, powered system, like let's say, here I got this little power station, right? This is from Pecron. So Pecron, I love this station, by the way. This is an awesome station. It's pretty heavy, man. It's got a lot of power for how small it is. So, okay, look, let me show you one other station. This EcoFlow. Love this guy too. You notice one thing they have in common? They're both plastic. All right, so are they plastic because it's cheap? No, plastic's more expensive than metal. I mean, maybe the raw material's not, but making metal, bending metal, cutting out holes, that's a lot easier. If you're going to build a project at home, are you going to go out and mold a box and pay for the tooling? No, you're going to take some metal, fold it over, drill some holes out, and you're going to make a metal box because it's cheaper, easier, right? Especially when you're doing lower volume. When you start doing a higher volume, you can start paying yourself back for doing all the molding for all these things like rubberized plastic handle. I mean, this stuff, putting these rubberized corners on this plastic, that stuff's not cheap, it costs more. So why do they do it? It's safer. See these receptacles? You have your line, neutral, and the ground. But the ground, this is also honest, because that terminal for the ground is huge, and you can see it's plastic. There's no metal in there. So it's kind of a giveaway that it's just a place for your ground plug to go, but you're not making a ground, okay? There can be safety issues with that, but you can't get shocked by this. If this is a metal housing, there could be some safety issues. Whatever tool you're using, if it has a metal chassis, that's tied to its ground, which is not tied here. So if this is metal and your metal tool, like a drill or something, was metal, you could get shocked, okay? So that's what I want to talk about. The easiest thing to think about when it comes to ground. Forget about the word ground, whatever it is. You know, and it really drives me crazy. And I don't know if this is something more used, this terminology more used in Europe. Let me know what you guys think in the comments. But I heard earthing wires. Listen to these guys talk about their systems, and they're talking about earthing wires. I'm like, earthing wire? You mean ground wire, safety ground wire? Earthing wire? The only wire I could think of you would call earthing wire is the one from your power panel where they call it service entrance, where the power comes in, serves the structure, the building, the house, whatever. That's a service entrance. And at that point, you'll take the neutral, bond it to the ground. That's the only place in the structure where it should be bonded to ground, okay? Then you'll put a grounding rod into the ground. Only place. That grounding rod, forget about it. When you're in your house and that grounding rod, let's just forget that. I mean, the meaning of that has little to do with anything, okay? If you're in a plane and the same power system, do you ever rod to ground? No. But you know what you do have? You have a lot of metal around you, right? So that's what I want to talk about. How you can get shocked by metal cases, okay? So whatever you want to call it, what you want, like any of these metal things, I know I can touch them and I won't get shocked, okay? And the reason why, well, this thing just floating, it's a resistor box, but you know what I'm saying, okay? And the reason why is, and you know what? There's so many things that are plastic nowadays. And again, it's for, one of the things it does, it serves for safety, okay? If you have a metal box, you have to have that third wire, and it has to be tied to the chassis. So let's call it chassis ground. Let's just call it our chassis connection, chassis wire, whatever you want to call it. Like when people, you know, when, and maybe even in, maybe even in their code books, they call it the earthing wire. It's just wrong. It's just a bad thing because it makes you think about a thing in the wrong way, I think. My personal opinion. This is all my personal, this is like a rant. I should have done this on a rant Friday or something. Should have had a beer sitting here talking about this because I could rant about this. So, all right. So let me jump to this inverter. Okay, it's a 3,500 watt inverter. It's a beast. This is from Vivor. Thank you, Vivor. This is awesome. I want to build a power system. So I've been watching other people, a lot of do-it-yourselfers. Hey, they might not be engineers like myself, but you know what? They've been building systems and they know something about them, so I want to learn from them. But then I hear them talk about grounding, and I'm like, and I hear, you know, some other things, and you know, you kind of have to go, well, hey, these guys are, who knows what they do on their day job, and much respect for learning so much about electronics that they can build these systems. But the one thing, you know, so I'm hoping I'm reaching out to these guys too. Now, by the way, I took the old plastic plate off this because I just want to show you. There's 3 terminals here. That's the same as these 3 terminals. This is metal, okay? So that grounding plug right there, that, you know, a thing that, you know, by code, you have to have that green, might be yellow and green, but it has to be, or bare wire, okay? Tied to that, to the metal. Has to be, okay? It should be. I can tell you that some of these power stations, they don't do it. And that's dangerous, okay? If you have a metal power station and that is not tied to that, that's dangerous, okay? Okay, so say 60, 70 years ago, whatever it was, they didn't have that grounding wire. You know, you had 2 wires, and what they call it, knob and wire, something like that. They ran hot and neutral through the house and on these knobs and everywhere, and there'd be fires, but people would be getting electrocuted and killed, you know, and so they had to solve that problem. And you know, think about the washing machine and the dryer. I talk about those two things because those are like the worst culprits. Okay, why is that? Well, first of all, they're metal chassis, right? So, and they both have motors in them. So electric motors are moving parts, obviously, and that's where you can have shorts. So you can have a wire short to the stator. Okay, so if you have line power short to the metal, which that happens often, right? If it does, and you have a ground tied to the metal, as soon as that touches, you got a lot of current going from that line wire to the ground back to the circuit breaker, and it pops it. Okay, so that saves you. Otherwise, there shouldn't be really any current. There might be a little leakage current because of filter capacitors, but there shouldn't really be any current on your ground. Okay, the reason it's there is to tie all the metal chassis together, and that's what I'm talking about today. Is forget about the terminology. Number one, make sure all the metal has a wire tied to it. Okay, like now if it's low voltage DC, that's something else. But if you have AC power going to anything with metal, even a BNC connector where you can touch it and that could have 120 volts on it, then, or in other countries different voltage, right? But see, these are plastic, that's great, you know, but if you can touch two things that are metal on two different boxes and potentially a wire came loose, a motor shorted, something like that, and you've got line connected to the metal chassis, maybe on this power supply right here, and I'm holding this, and I reach over and I go to touch something, you know, and I hit this metal handle. This has a metal chassis. A lot of these older devices have metal chassis, and you know, some of the newer devices have metal chassis too, right? Now on the faceplates, a lot of plastic. It's kind of protective, right? So the thing is all those chassis should be tied together. So when people are building these systems with individual metal boxes, tie a freaking wire from one box to the other box. Okay, make sure they're tied together. Make sure all your metal boxes are tied together with a wire. We don't have to call it ground. We don't have to call it safety ground, chassis ground. We don't have to call it anything. For me, I'd call it chassis ground. Okay, but you know, I don't care what you call it. Okay, just make sure all your chassis are tied together. Okay, whether or not that thing is tied to this or not. Okay, maybe some inverters, some things, they're not tied to this, and if they're not, now there's a neutral to ground tie. We're not going to talk about that in this video. All I'm talking about is making sure all your metal things that have AC voltage going into them, make sure all the metal has a actual wire going from one. Don't just mount them all to a metal plate. Okay, I mean, that's better than nothing. If you do, make sure you scratch off the paint so that it makes a good contact. But what you want to do is scratch off the paint, put a washer and a nut, and make sure that you have a wire that goes to the next metal thing. So all of them, you know, they're all referenced to the same voltage level. So it doesn't matter if it's ground, if it's floating at 200 volts, whatever it is. You want to make sure all your metal are all the same voltage plane. They should be 0 volts. They should be ground. All your chassis grounds should be tied to your safety ground that goes back to your, well, in the case of a home or something, that goes back to your receptacle. In the case of a floating system, all you can do is tie all the metals together. Okay, make sure all your metals are tied together. Your powers could be floating coming out of them. All right, and if they are, try to get devices with 2 pins without a ground. Okay, because you don't have a grounding connection if in certain cases. But anyway, I don't want to get into all that stuff. Just forget about all that stuff I'm saying. Just only remember from this video, make sure all your metals are tied together. Okay, rule number 1. If you do that, then don't worry about these terminals. Don't worry about these terminals. Now, I can show you, like on this guy right here. I use my handy little Zotac here. Look, I can see the green wire coming out, green and yellow. That makes me feel good because I'm thinking like, okay, that's connected. First thing I did is I went to this little screw. Nothing. That made me worry because all these metal things. But what I'm thinking is those little metal guys, yeah, I don't know why they're not making a connection, okay? But, so that got me worried. So then I went to the chassis. Got to make sure I put that in ohms. When I hit the first time, it just woke it up. Okay, let me go back to that little screw. See if I touch them. I don't know if you can hear that.
0.09 ohm.
She said it was 0.09 ohms. So, but if I go to this guy and touch this, nothing. So that made me worry. But then I went to the chassis. Sorry, kind of slipped off that. So if I go to chassis,
7.62 ohm.
now there's some paint here. That's a problem.
0.55 ohm.
0.55 ohms. So
3.08 ohm.
So see, there's some paint on this. So when I mount this, I'll make sure I rub that paint off. But I am so glad that that safety ground right there is tied to the chassis. So thank you, Vivor. Now, if I go to this little plug-in here, which you want to check that, guys, because I've seen cases where that's not wired.
Over range. 0.05 ohm. 0.04 ohm.
All right. So thank you, Vivor. I'm happy about that. Okay, that's number one. That's your number one safety right there. It's awesome when you're that green wire, when this thing builds an AC voltage off that 12 volts coming into it, it ties that green wire to this. So now if I plug something in here and it's something metal, a heater, a drill, whatever it is, something that's metal. All right, so if, you know, whether it's that drill or the toaster oven, whatever it is that plugs AC into here, I want to make sure anything that plugs AC into here, that their chassis are the same as this, same potential. So I want to tie green wires, same potential, same reference point. I don't give a crap what you call it, okay? Call it chassis ground, call it earthing ground, which is, in my mind, stupid. It has nothing to do with earth, guys. Nothing. Zero. It has to do with this green wire being bonded to that neutral wire, tripping a breaker. The earth has nothing to do with that, okay? So, in this video, I'm not talking about earth ground, not talking about all that kind of stuff. I'm talking about safety and protecting you from touching one piece of metal that has AC power on it, touching another piece of metal with AC power on it that's being powered by this, and getting electrocuted, okay? Shocked, whatever you want to call it, okay? Hopefully it's not electrocuted, but hopefully it's just a little shock that you learn from. But hopefully that doesn't happen either. So it does need to have some paint rubbed away wherever I end up putting my thing. And I have not read their manual to see if they tell you to do that. I don't care what their manual says as far as that goes. I'm going to bond this thing to any other thing that's metal that has AC on it. Okay? So, or that potentially could have AC. I might have a motor mounted on something over there, right? I want that motor chassis and this chassis to be the same potential. All right. I should have called this a rant video because, yeah, I just kind of wound up today watching a video, watched a few videos, and one of them, you know, the guy was talking about earthing wire. I'm like, all right, you still haven't told me how you connected your stuff. I mean, he connected some things together and he did a lot of things right, but I didn't hear him say what I said just now. And making sure this metal is tied to that ground terminal, okay? So, okay, guys, sorry about that. There you go. Let me know what you think. Chassis grounds on all your AC devices, anything that's powered by this guy, that's, you know, by the AC end, This doesn't have any DC. It's an AC inverter. It does have this USB, so I don't know what where. I don't know if that's on the secondary side or on the 12 volt side. So I don't even know about that. All I care about right now is this. Okay, and okay, guys, there you go. I hope that helped someone. I hope that helped protect someone. Understanding, because I've seen some things on videos where people are not tying their chassis together, and they're putting things inside cars, building solar, power systems inside their car, and they're not tying them to, like, the problem is they hear the word ground and they think like the 12 volt ground is what we're talking about. We're not. See, that's the problem. That's 12 volt ground. That's 12 volt return. If we call it 12 volt return, it'd be obvious that when we say ground, earthing ground or safety ground, I hate earthing ground, but when we say safety ground, we know that that'd be completely different than 12 volt return, right? Okay. By the way, one time I built a system that was going on a Navy ship, and it was going to be, what was it? 270 volt DC. Okay, it's going to power a communication system on a ship. Okay, and it was going to be, my power system is going to be under deck and lower decks, and this communication system is going to be way up on a mast. So I called it plus or minus 135 volts because I didn't want any bonehead thinking that my return was a ground. All right. So anyway, there you go. Okay, guys, let me know what you think. Thanks. Just had to get that off my chest. Maybe I will put the word rant into this title so it'll kind of explain my, my feelings about this whole thing, that I might have been on my soapbox a little bit. So sorry about that. And all right, guys, thanks for watching, and we'll see you next time.